Okay, we're gonna start solving systems of equation by using graphing, but let's look at this first equation first. We want to be able to use a graph to find the x value when y equals 3 and our line is y equals 2x minus 1. So this line is already in slope-intercept form, so we know that the y-intercept is -1, and the slope, which is the coefficient of the x, is 2, or 2 over 1. So we come over to our graph paper, and we're going to graph 0, -1, our y-intercept, to be our starting point. And from there, we're going to use the slope to get another point. So we go up 2 and to the right 1, and up 2 and to the right 1, and up 2 and to the right 1, and that gives us a series of points to help us graph our line. Now let's join that in a line. And now what we're going to do is we're going to graph the line y equals 3, which, as you know, is a horizontal line right through y equals 3 on the axis here. So let's just draw a horizontal line at y equals 3. There it is. And so the x value when y equals 3 of our line y equals 2x minus 1 is the point where the two lines meet. That point is 2, 3, so that tells us that our x value is 2. So that's how to solve an equation using a graph. But now let's solve it algebraically, and this is the form that you're most familiar with because we've been working on this in the last couple of chapters. So we're going to check that. Actually, we're going to go ahead and substitute 3 in for y in our original equation, and then we solve for x, and notice that we get x equals 2. Okay, now we're going to do b. This is a little bit more complicated. This is our line in standard form, and we're going to get it to slope-intercept form by solving for y. So we add the 3x to both sides. That gives us 2y equals 3x plus 12. And now we need to divide everything by that 2 so that we can get y by itself. So we get y equals 3/2 x plus 6. And this time we're going to use our graphing calculator just to give us practice. So we're here at our y equals button, and we're going to type in the 3/2 x plus 6. I use the parentheses to keep the slope together. And then this time we're going to also graph the horizontal line y equals 3. Notice how we're graphing both. y1 is the first equation, y2 is our y equals 3. Now we're going to look at the table of values and notice how we get the x column, but then we get the y values for both lines. And we're looking for where those y values are the same. And as you can see here, when x is -2, y1 and y2 are both 3. So that is the point where the two lines meet, and that gives us our x value. X is -2. So now let's use the values on our table. We're going to use the values to draw our graph. But here's the graph. This is what it's going to look like. Okay, and so we're going to use the values to graph on our graph paper. And the first point I'm going to graph is -2, x equals -2, y equals 3. And then I'm going to graph 0, 6. I'm just picking some points from the table. And now we're going to use our line tool and draw our line. For the first, this is the line given in the problem. That's part B. And then we're going to do like we did in the last example. We're going to graph our horizontal line y equals 3. And notice how both lines do meet at that -2, 3. So x is -2. That's the x value, and that's how you solve an equation graphically. Now we're going to solve a system of linear equations in two variables, and that means you're going to have two equations that have this general format. A number times x plus a number times y equals a constant. And you're going to have two equations where all of these coefficients may or may not be the same. And here's an example of a system of linear equations. We have x plus y equals 8 as one line. Our a and our b are 1 and our c is 8. And then we have x minus y equals 2. Our d is 1. Our e is -1 and our f is 2. So these two equations follow our format for a system of linear equations. And as we know, both of these equations the graph is going to be a line. So the solution to the system of two equations is going to be an ordered pair, and it's the ordered pair that makes both equations true. And graphically, that means that's the point where the two lines intersect, just as we've been doing in the last couple of examples. Okay, in this problem, we're going to determine whether the ordered pair is the solution to the system of equations. So we're given the ordered pair -1, 2. We're given the system of equations, and so we're going to substitute in our -1, 2. And remember that this point has to make both equations true. And so it definitely makes the first equation true. And it's looking like the second equation, I also get a true statement. So by substitution, substitute in the -1, 2 into both equations and check whether you get a true statement for both. Then that will be your solution. Okay, now we're going to solve this system of equations by graphing. So let's put the first equation in slope-intercept form by solving for y. So we're going to get y equals x minus 3. So of course you know that means that we have -3 as the y-intercept. We're going to put a starting dot there, and that the slope is 1. So we're going to go up 1 and to the right 1, up 1 and to the right 1. Use our line tool, and that is the graph of the first line. We're going to repeat the process with the second line. 2x plus y equals 3. We want to get that into our slope-intercept form, so we're going to move the 2x over, make it -2x plus 3. And our y-intercept this time is a +3, and our slope is -2, which you know will be -2 over 1. So let's graph our y-intercept, -3 on the y-axis. Then we're going to go down 2 and to the right 1. And this is kind of cool when you do that and you already find where the two lines meet, as we just did. But here's our graph. So both lines meet at the point x equals 2, y equals 1. You can read that from the graph. And now we're going to check that. So the solution to our system is the point 2, -1, and we're going to check it. And again, remember, you check that by substituting your solution into both equations and showing that you get true statements. So we're going to substitute x equals 2, y equals -1 into our first equation. And so I get 2 minus a -1. Does that equal 3? Well, yes it does, because this is 2 plus 1 on the left, and that is 3. Now we're going to check by using the second equation. Substitution again. So 2 times 2 plus -1, does that equal 3? Of course, that's 4 minus 1, so that does equal 3. And so 2, -1 is the solution to our system.